The buffers lab is another 2-week lab, and it's going to be done in groups. The first week of the buffer experiment, we want you to do parts 1 through 3. And in the second week, we'll have you do parts 4 and 5. So that's how we're going to split it up. You are going to be working in groups of 4 for a nice division of labor. And you also need to print the worksheet. Okay. This is a worksheet you're going to be turning in at the end of the second week. For parts 1 through 3, you're going to be making a number of solutions of buffers, starting from a solution of a weak acid and a solution of a weak base. You're going to be mixing those together in various ratios and then doing some experiments with that. One of the things you're going to measure is buffer capacity. So buffer capacity is a measurement of the ability of a buffer to resist change in pH. And the way this is calculated is we determine the moles of H+ or OH- added to the buffer of a known volume, and we determine the pH change. So the way you're going to do this is you're going to have a beaker with some volume of your buffer, and you're going to add a pH electrode. And then you're going to use a burette and add in either base or acid, and you are going to do both of those. You can split this up into your group. And you're going to measure the amount of the volume of the base or acid added, see what pH change occurs, and then knowing the volume of the buffer, you can calculate this buffer capacity. How much buffer or how much acid or base should you add? Well, you don't want the buffer to break down. You still want it to be a buffer. So it shouldn't completely go acidic or go completely basic. It needs to be close to its original pH, but some significant change needs to happen. And then whatever volume that ends up being. So kind of monitor that pH change. I think a pH change of around 0.5 or 1 unit should be reasonable, but it's going to be different for all the buffers that you make. So that's going to be parts 1 through 3 in general. Parts 4 and 5, you're going to be making more buffers. In part 4, you're going to be looking at one of the same systems that you looked at in parts 1 through 3. You're going to make a buffer from a weak acid solution and adding into it the salt of the weak base, and looking at the pH from there. You're also going to be considering the ionic strength and activity of the buffer. And there are 2 equations that you're going to need to be familiar with. The first one here is the Debye-Huckel equation. And this is useful when the ionic strength, which is given by mu, is less than 0.1 molar. And so from this equation, you can calculate the activity for a particular ion. So Z is the charge, mu is the ionic strength, alpha is the effective radius of that ion. The second equation here is the Davies equation, and this is for when the ionic strength is between 0.1 and 0.5 molar. Okay. And this is the Davies equation, so you still have to worry about the charge on the ion. Here's your ionic strength. It shows up here. And this equation doesn't worry necessarily about the radius of the ion. So parts 4 and 5, you're going to be looking more at ionic strength and activity. Like I said, part 4, you're going to be working with a previously made buffer system. In part 5, you're going to be working with a polyprotic buffer system. And you're going to be mixing 2 salts together in order to make that buffer.